to MemComputing.
Hi, I'm John Bean. I'm the CEO and co-founder of MemComputing. We're disrupting the high-performance computing market by delivering the performance expected of quantum computing with our non-quantum solution. Next slide, please. The scale of many optimization problems today, like routing, scheduling, analytics, and AI, is such that it would take years to create an optimal solution. So companies are forced to rely upon approximations, and this leads to cost inefficiencies that can add up into the tens, if not hundreds of millions of dollars on an annual basis. Quantum computing is looking to address this, but quantum computing is still in its infancy and is at least 10 years away before it will be available. Next slide, please. That's where MemComputing comes in. Like quantum computing, MemComputing is a physics-based approach to computation. MemComputing is harnessing the power of the physics associated with digital circuit design in ways never before imagined. We completely reinvented standard logic gates by developing self-organizing logic gates, or SOLGs. They eliminate the bottleneck associated with current computers where the CPU and memory are separate. Instead, each SOLG is a mini processor with memory. SOLGs negotiate to solve a problem in a highly parallelized fashion. Each SOLG is aware of all changes in the circuit as they occur. In physics, this is known as spatial non-locality and is very similar to quantum entanglement. But with MemComputing, we're able to do this at scale. So MemComputing circuits act more like a brain than a computer. Next slide, please. Our virtual MemComputing machine is our first product. It's been live since 2019. It's a cloud-based compute as a service solution, and it is free to evaluate. This year, we'll be releasing a MemComputing-based training system for neural networks. And with a proof of concept that we've done with a customer to date, we took a neural network that takes them over 2 weeks to train and retrain, and we're able to train it in 6 hours. And in fact, we produce more accurate training as well. We're also in the process of developing our first MemCPU integrated circuits. The first one will become available in 2022. These are designed for real-time computational needs. And our first focus will be on image processing and also on another one on 5G communication. Next slide, please. So let me share some examples of our virtual MemComputing machine in action. So the Port of Singapore came to us with a port optimization problem that was scaling exponentially for them. They gave us many sizes of the problem, and the smallest of which was taking them over 70 hours to compute. With MemComputing, we solved that problem in less than a second. The largest version of the problem, which is essentially meets their production needs, was something that was expected to take years to solve with current methods. With MemComputing, we solved this problem in less than a minute. Next slide, please. Another example comes from the Airbus quantum computing challenge. Somebody's got their sound on, by the way, where they presented a list of problems that were identified for quantum computers. We took one of those problems related to the optimal loading of cargo on an aircraft. It's a problem that's intractable today. Obviously, companies are loading cargo, but they are forced to use an approximation. So quantum computing is expected to solve this optimally, but again, it's at least 10 years away. But with MemComputing, we solved this problem at scale today, providing an optimal solution, and it takes us less than 7 minutes. Next slide, please. So we're focusing on the high performance computing market with a targeting the transportation, logistics, oil and gas, and Department of Defense, areas where we already have quite a few customers. Next slide, please. And financial projections, 2020 was a little slow. Things were delayed because of the pandemic. However, 2021 has been a very strong year for us. We've already booked more than half of the $1.5 million that we expect to earn this year. Next slide, please. We have raised $3.25 million to date. We have another note open. Those are all through notes. And we expect to raise a Series A in the first quarter of next year. And last slide, please. So joined as co-founders, the two inventors of the technology, Dr. Fabio Traversa and Dr. Max DeVentra. I'm a serial entrepreneur. My companies have returned more than $1.5 billion to investors at about a 12x return on average. And we're joined by a small but dedicated team of engineers and scientists that have done an incredible job bringing the product to market and supporting our current customer base. Thank you. I'd be happy to answer any questions you may have.
John, does this technology and quantum live side by side in the future, or does quantum eclipse this?
No, well, we actually think that we eclipse quantum. We're addressing at least 80% of the problems that quantum computing is going after today. But the thing to consider is that we're both a software solution and a chip-based solution. So things where and we're working with the DoD on satellite-based problems. So you'll never see a quantum computer on a satellite. You'll never see it on a drone. You'll never see it on a airplane. You'll probably never even see it on a ship just because of the environment. But you'll see our software and our hardware on those things.
I'd be curious for the hardware, John, on the unit economics and also the design system that you integrate with and scalability for the future.
So yeah, we're still in the early stages. We're working with an aerospace company right now and doing a feasibility study on a chip to do image processing, real-time image processing, as I stated. So it's really too early to answer those questions that you've asked. I'm sorry.
How much do you estimate, John, the market opportunity for high-performance computing? The TAM, if you were to make an assessment of the TAM today, and how you would think about expanding the TAM in the future?
Sure. So right now, just looking at the 3 target markets that we have, we're looking at I think it's a $2 billion TAM. That's just, however, that our technology is virtually every industry can take advantage of our technology. So the full TAM, or the full market, I think, for, if I go back to that slide, I think it was like 38 billion for high performance computing. But the expanding the market is that there really isn't much of a market for quantum computing today, and we'll take on a lot of that. So for quantum computing, I think the market is $500 million. But that's because quantum computing is in research and development phase, and I think where they expect it to go will be in the many billions of dollars. And that's an area where I think we can take a strong leadership role just because of the availability of our technology and the flexibility as well.
Thank you, John. From MemComputing, that was excellent. We're moving right on to our last presentation.